Tamarai Selvi is working as a professor in the Department of Computer Technology, MIT campus of Anna University, Chennai. She has over 30 years of teaching experience. Grid computing, cloud computing, and e-learning are her areas of interest. She has successfully completed 12 research projects funded by Government of India and Tamil Nadu state government. She has established Center for Advanced Computing Research and Education and acquired 1 patent and has filed for 3 more patents in her research area. She has presented over 110 papers in international conferences and published 45 papers in international journals. She has authored 5 books. The latest book is titled Mastering Cloud Computing, published by Morgan Goffman Publishers 2013.
Welcome to UGC lecture series on cloud computing. We are discussing about the virtualization topic in the few episodes. Today also we are going to discuss about the storage virtualization, and we are going to discuss about the various research activities in which we have used the virtualization concept. Now, to start with, let us just discuss about the storage virtualization. Similar to computing resources, network resources, it is possible to virtualize the storage units also. I have taken all these slides from University of Manchester, thanks to the professors who have contributed in a fantastic manner. See, there they have given the storage virtualization with a beautiful diagram. So, you are having the device drivers and you are having the OS and you are having the file system also. You are having the various storage units in the distributed manner. Here you are having the file system code, and also assume one file system to one disk drive partition. So, you can have the various striping or mirroring or write changes also, and storage virtualization, it is breaking the file system and also it drives the relationship. That is the main conceptual idea. See, logic volume management is one type of storage virtualization we can say. Here virtual mapping between the file system code and physical devices are actually done. It is analogous to the virtual memory addressing, even though it is not exactly identical, and volume group of all drives in a pool is considered, and storage space in volume group divided into physical extents, and usually all are of the same size, and logical volume is set of the physical extents. So, this is what we are having the concept in LVM. So, in the logical volume management, you are having the device driver and you are having the group of volume available, and that LVM layer is in between these device drivers and file system. It is possible to have all the possible thing with the LVM layer. You can resize the file system also, and you can have the snapshot of the live file system also. The main purpose of that snapshot is while transmission, if some error occurs, then you can simply redo the process, you can resend it. For that purpose, we are having the snapshot whenever it is needed. So, that facility is also there. So, when you consider the LVM, we can share the resources more flexibly and also more efficiently. It is not necessary to consider a single server alone. You can consider the different servers, so that from all the servers you can take the hard disk capacity and you can just have the LVM to have the virtualization. Then you are having the storage area networking, that is SAN. Here it implements the LVM features in separate storage controllers, and it connects multiple servers to storage controller, and it uses the media such as SCSI or fiber channel or InfiniBand like that. And SAN over the Ethernet is conventionally called network attached storage, NAS. Now, you can share the disk resources across multiple servers, and also rapid migration as well as disk image copying is possible. So, these are the major advantages of this storage. As we have discussed in the last episode, when we are able to virtualize computing resources and network resources, the remaining part is the storage area networking, or you are trying to have the storage virtualization. Normally, when you perform any computation, you need the computational power, then you want some storage area to store the data, input data as well as output data. Then you want the network virtualization to have the proper connectivity across the nodes. So, all these three should be considered. So, SAN is one such application of this virtualization. Whenever you are having the storage area network controller, you are having the SAN controller which is managing the different memory available in the aggregated blade servers. This is the aggregated blade server. So, from that server it is possible to have the SAN controller and get the different storage unit to be connected to it. So, it is also possible to get the virtualization similar to our SDN controller. Here we are having SAN controller. It is possible to attach different storage devices connected to a computing resource, and it is possible to map it by using the SAN controller, again load balancing as well as other traffic monitoring, and to which one it has to be transferred. All those things are possible, and this is similar to our network virtualization and computing virtualization only. You will be having a limited capacity of the physical resource. It will be available in different locations. Then you can aggregate all the storage units, or sometimes you are having the units available in different locations and you are trying to aggregate all those things and store it in a single place, and it is possible to access that stored data by any user. So, that is the main advantage of those things. When you consider the key features of SAN, first thing is system virtualization. Second one is migrating virtual machines. It is possible to migrate the virtual machine itself, because virtual machine is also an image stored in that one. Once if you have the snapshot, just you can transfer it. Then deduping, that means sharing common subsets of the file systems. It is more or less similar to the virtual machine images, and the management part of the SAN is managing the storage separately from server physical resources, and also maximize the flexibility of the storage provisioning. So, based on the availability of the nearby location storage device, or based on the connectivity available across the various computing resource and storage resource, it is possible to have the storage provisioning and you can have the flexibility. So, this is the actual advantage of keeping the storage virtualization in the cloud computing. Then another one is ZFS, that is volume over file system. Here Z series file system is known as ZFS. The main purpose of this file system is to provide solution for various problems which are faced now. See, you are having a pools of storage. For all those things, it is the storage. Like that, you can have the pools of storage in different locations. It is not necessary to have a very big end storage. You can have the medium storage also shared for small tasks. The main challenges that are overcome by this ZFS are recovering lost files. See, it is possible to have the mirror image of the files whenever you are having it. Of course, you should provide another standby hard disk capacity. It is possible to recover the lost file. Then you can provide extra space whenever the existing space is full. You can just dynamically add the extra space. Then it is actually avoiding the difficulty for upgradation of the disk. You are having the limited capacity. You can simply increase the capacity without any difficulty. Then elasticity. Elasticity means you can just grow or shrink. When you want to increase the capacity, you can increase. Whenever you want to reduce the capacity, you can reduce it. Then it is possible to avoid the data corruption also. If some data is corrupted, if the data is having more noise, again you can resend the data and then you can get back the original data. So, like that, this volume over file system is having lot of advantages, and in the industry the people are really talking about the various virtualization concepts. Cloud is almost dominating all the industries because of various opportunities as well as advantages, and the main concepts behind the cloud computing is virtualization. That is why we have discussed about the virtualization of computing resource, virtualization of network resource, virtualization of storage resource. Even though the fundamental concept is meant for making use of the physical resource into virtual resources, the various controllers or hypervisors or virtualizing concept is different for computing resource, it is different for storage resource, it is different for network resource. So, we have discussed about the storage virtualization right now, and based on these three types of virtualization, it is very much easier to develop any fruitful application with lot of flexibilities and also with lot of extensibility. These are the various advantages. So, after completing this virtualization concept, let me focus our attention on various research activities which we have done in our Center for Advanced Computing Research and Education, known as CARE. See, we have developed our own resource broker for both grid as well as cloud. After working in that resource broker, we got lot of ideas, and based on that experience only we are able to do research in that area further. So, just I want to highlight some of the important projects we have completed and also what are the things we have completed and published papers, all those things I am going to highlight. So, it is possible to view the CARE activities using this URL. The first research which we have done is developing trust component for the meta scheduler. Like cloud resources, grid resources are also available. While doing the research in grid computing, we actually developed the trust component for the resource. Actually, in case of grid computing, you will be submitting the job from the client side to a resource broker. That resource broker has to identify the suitable resource from the existing resources, and after the job is executed, the results are sent back to the user. So, for that purpose we are using so many grid middlewares such as Globus Toolkit or G-Lite or GridBus Broker, or you can make use of Unicore. Lot of grid middlewares are available. So many scientific computations are done with the help of grid middleware only. The users may not be aware of the various functionalities of the various resources, the environments available in it. It is the responsibility of the resource broker, or we call it as meta scheduler, which will identify the actual resource in which the job has to be submitted. The user may be from bioinformatics application, the user may be using a CFD application, the user may have weather forecasting. So, from different disciplines you will be getting the applications developed in a distributed manner, and that application has to be executed in a very high end computing. There you are having lot of resources registered to the resource broker, but over a period of time when all the resources are being used, it is possible to calculate the trust of each resource. Trust means the degree of belief you are having over that resource. How to calculate it? So far many researchers have developed the trust component based on the various subjective manner. Subjective means getting the feedback from the user. Yes, this resource broker has successfully completed it. This resource broker is efficient. This resource broker is not at all available. Like that, based on the feedback obtained from the people who have submitted the job, the actual feedback was evaluated and the trust value was given. But the problem is, whenever it is a subjective one, some people will take it as excellent, some people will consider it to be good, some people may be considering it as satisfactory. So, it depends upon the individual's expectation. So, it may not reflect the actual trust of the machine. So, we wanted to have some objective parameters to be considered for evaluating the trust. For that purpose only we designed and developed trust component for the grid scheduler, and also we have integrated with the gridway meta scheduler, which is a resource broker for grid resources. And after developing that particular trust resource broker, we have integrated with gridway meta scheduler, and you can refer to this URL where our trust component is given here. It is the gridway website, it is the University of Madrid in Spain, that team is doing it, and here also they have given who are the developers or the contributors for the gridway. So, you can refer to this website. What we have considered is the success rate, availability, and also system profile. The success rate means out of 100 jobs you have submitted, how many jobs that resource has successfully completed. If it is 80 means 80 by 100, it is 0.8, trust value is 0.8. Like that we identified the percentage of the completed job for each resource. Initially you will not have any value. So, we started with 0.5. The trust value may be increasing or decreasing based on the performance of that resource. No user is going to give any feedback. Once if it is successfully completed means accordingly it will be added. Similarly, to know the connectivity, see you are knocking that resource for 100 times. If there is connectivity, then we are having that connectivity value by having the availability. Availability means out of 100 times it was available for 90 times. So, 90 by 100. So, we made everything objective, and each and every time the job is submitted to the resource, automatically the trust value is upgraded, and you will be getting the exact trust value of that machine after a period of time. If you are having 10 resources available, whenever the job is submitted, the resource broker is going to identify which is the best resource for that job. The trust value will be used as a measure to identify the trustworthy resource. So, that was the research we have done. The outcome of this research is got a patent in the title "A System and a Method to Assess the Trustworthiness of a Resource Provider," received in the year 2010, and international classification is this number. So, this is the outcome of this trust component which we have completed. So, to have the overall view about this one, we have discussed about the various research activities which we are pursuing, and in that I have discussed about the trust calculation of grid resources which we have done as part of our research. Let us have a small break. Welcome back to UGC lecture series. Actually, we were discussing about the various research activities in our research laboratory. The next research I want to explain is that virtual cluster development environment, VCDE. The main purpose of this VCDE is to create virtual machines in a remote potential physical resource to meet the CPU requirement of an application, and also create a virtual cluster in a remote potential physical resource to meet the application's platform requirement. So, the real purpose of this research is to create the virtual machine on the fly or dynamically create the virtual resource in an available physical resource based on the demand of the application, and also after creating multiple virtual machines you form a cluster to create the virtual cluster. This is the purpose of this VCDE. So, we developed the virtual cluster development environment and we published that paper in Globus workshop, and the Globus team asked us to develop the incubation project called GT auto install, that is the Globus toolkit has to be installed automatically. So, we developed that one and you can refer to GT auto install from the website. You will be going to this particular page. From there you can come to this www.annainu.edu/care. There you are having the entire procedure for auto installation of the Globus toolkit. So, this is our next research. You can see who is the project chair, that is Dr. Ruben from University of Madrid. He is the person who is mentoring this incubator project, and since we have integrated our trust component, we had the communication with that team also. The next one, we have just extended the virtual cluster development environment to the care resource broker. The resource broker is meant for providing the features to identify the suitable resource, get the things done and return back the result. That is the actual purpose. So, we used these features in care resource broker. On the fly, you have to create the execution environment using appropriate virtual machine images, dynamically create grid environment by automating the Globus installation and configuration, creating virtual machine and attach it to a existing cluster, and we are discussing with Garuda grid, which is our Indian national grid, to integrate the CRB with this Garuda grid. This is the actual architecture of the CRB. See, you are having the fabric layer, then you are having the resource connectivity layer. These are all the things available in Globus toolkit itself. In this collective layer and that application layer, we have developed so many things. See, originally grid was not considering the virtual resource created through hypervisor. So, we started using the hypervisor to be incorporated, so that whenever you are having 10 nodes, whereas the job requires 13 nodes, you can create 3 virtual machines and attach it to the existing cluster having 10 nodes. So, 10 physical nodes, 3 virtual nodes, totally 13 nodes are satisfied. So, we created the virtual machines in the physical machines which are available free, and those 3 machines are connected to the existing cluster. So, like that we developed the various modules in this layer to automatically create the virtual resources. So, how it is working? See, this is the CRB, you are having the different resources. Whenever the job is submitted, you are having the scheduler, it decides where to deploy the virtual resource. Then we are having the virtual resource manager maintains the virtual resource information, and virtual cluster service, virtual machine service, they will create the virtual cluster or virtual machine respectively. So, it invokes the virtual cluster service, because in this physical machine only it is possible to create the virtual cluster. After that, in the head node, that VCS selects the potential compute node, and if it is possible to create the virtual machines here, then both are clustered together. So, this is done automatically, and we will be giving the certification for the purpose of security, and job is submitted through Globus. So, virtual machines had been created and virtual cluster had been automated. So, based on that we have just filed a patent for the CRB. Still it is not yet over, it is under process, and we have published the journal paper in Future Generation Computing Systems. You can refer to this. Then next one is virtualization enabled desktop grid. This is a consultancy project for Honeywell Technology Solutions. They gave this problem like this: we have to build a supervisory system that manages the virtual machine to run the job whenever the overall grid utilization exceeds a specific configured load. So, they have defined like this: we have to build a VM forms that consists of pre-configured VM images with Red Hat Enterprise Linux as its OS and a simulator software to run the jobs across non-dedicated nodes. I will explain which is non-dedicated node in the next slide. And also we have to build a scheduling mechanism that identifies suitable non-dedicated node, starts appropriate VM in it, monitor the job execution across the VMs and stops them after transferring the results. This is the problem. Actually, we had used SunGrid engine as the middleware. Then SGE execution nodes are the nodes which are connected to this resource broker. The nodes which are available in the office is called as non-dedicated nodes. The purpose is like this. See, they are having lot of applications like the ANSYS, CFX, Fine Turbo. These are all various applications they have to test in their Honeywell office. So, when they want to test various applications, they want to have the enough number of execution nodes, execution computers. With the SunGrid engine, they have connected about 20 nodes or 30 nodes. If all the nodes are engaged with some type of jobs and some other job is also coming, so what to do? They are using so many ordinary computers or PCs for the purpose of just mail sending or browsing or editing the documents. What they told was all the office computers are also having reasonably good configurations. Why don't we make use of that office computers whenever there is a need? During the night time and all, there is nobody working in that one. So, what they told was you have to pre-configure the office computers with 3 virtual images. They gave this image CFX, Fine Turbo and ANSYS. These are all the various software. They bundled it and the 3 VM images had been pre-configured and installed in the Windows operating system. They asked us to use only VMware. That was the suggested hypervisor. So, they provided the VMware enabled system in which these 3 VM images are there. Our job is to find out the load in this SGE whenever all the execution nodes are engaged and some other job is pending. We should just we have to just boot this particular VM and it should be connected to SunGrid engine on the fly. There is no shutdown or no, automatically it has to be linked with this one. So, we created the virtual images, it was installed in those things. Whenever there is a need, simply it will be connected to the SGE and jobs will be submitted to this one. So, for that purpose we developed this architecture and also we completed that work. After completing this one, it was installed in Honeywell Madurai. They are making use of this virtualization in their office also and now it is being extended for cloud. So, we use the VMware interface. So, in the management node as well as the non-dedicated node, we use the VMware APIs for the communication and we were able to just identify the appropriate NDN node whenever there is a need for it. That is the research we have done. The next one is service oriented care resource broker. We developed the care resource broker only for the purpose of this grid resource brokering, but it was only modular based. We wanted to use the service oriented based care resource broker by implementing all the functionalities using the web services concept. See, instead of web services, we use the grid services. Grid services are stateful services, web services. They are also web services, only thing is they are maintaining the states. So, we have discussed about 2 major contributions using virtualization. One is how to create the virtual machines on the fly and also how to form the virtual cluster on the fly. That is what we have done in care resource broker. There we use the Zen hypervisor and we have just created the virtual machine dynamically and it was connected to the existing cluster or it was created as a new cluster. So, from that we gained some knowledge in the virtualization. Then in the next one for the Honeywell, we did the project by using VMware. So, we got the opportunity to work with VMware as well as Zen hypervisor and we were able to understand the importance of virtualization, how to improve the resource utilization, how to make the successful completion of the jobs submitted, these two were very much useful by means of virtualization. So, the virtualization is very much helpful in so many aspects, and if you are able to install the simple hypervisors and test it, you will be understanding the concept. To review the various concepts we have discussed so far, you can just try to answer the following question. What are the advantages and drawbacks of Xen hypervisor? What is the difference between VMware and Xen? How can you create virtual cluster in any cloud environment? If you try to answer these questions, definitely you will be trying to understand the conceptual idea of virtualization. So, with this we can conclude this episode. Thank you.